Hello students, let us continue. Our next topic in the chapter is matter around a sphere, which is chapter 2. In the previous class we studied about the mixture, the types of mixture, and what is a solution, true solution, suspension, colloidal solution. So in today's topic we are going to talk about the other topics. So before moving on to that, we will first know about what is a saturated solution. Okay, so saturated solution is a solution which cannot dissolve any more amount of solute at a given temperature. That means at a particular time, the solution or the solvent gets dissolving with the solute particle. So this part is called as the saturated solution. And what is the solubility? Solubility of a substance is the amount of solute present in a saturated solution of a substance. Next one is unsaturated solution, is a solution which can dissolve some more amount of solute at a given temperature. That means even if it has reached the saturated point, but at a given temperature it can add some more amount of solute into it. So this is how we have to prepare the saturated solution. You have to take the beakers, 50 ml 2 beakers, and add salt in one beaker and continue stirring it till no more salt dissolve in it. Similarly, add sugar in the another beaker with continuous stirring till no more sugar dissolves in it. We get saturated solution of both the salt as well as the sugar. Okay, so when it reaches the saturation point, if you will heat it up, okay, when you will heat it up, it can dissolve some more amount of solute in it. So that means from the above activity we can say that the solubility of different substances are different, and the solubility of substance varies with the temperature. That means without heating it can add up to certain amount of solute, and after heating it can add certain amount of solute in it. So this is how we can calculate the concentration of a solution. Okay, so the concentration of a solution is the amount of solute present in given amount of solvent. As you all know, like if there is a test tube or a beaker, whatever we can say, okay, if there is water inside, okay, if this is water inside, this is called as the solvent. Okay, and if you will add salt into it, if you will add what, salt into it, for example this is the salt, okay, if you add salt into it, this will be called as the solute particle, and this will be called as the solvent particles. So the amount in what is the concentration of a solution, it is the amount of solute, that is this one, which is less in quantity, in a given amount of solvent. That means this is the water. So how can you calculate the concentration of a solution? The amount of solute divided by the amount of solvent. Okay, or you can also find out as the amount of solute divided by the amount of solution. Solution means the whole solution. Okay, whatever the solution it is there, with the help of these two formulas you can calculate the concentration of solution. Even this concentration of solution, it can also be expressed as mass by mass percentage and volume by mass by volume percentage. For example, in that if you need to calculate mass by mass percentage, what you have to do, you have to calculate by mass upon solute divided by mass upon solution into 100. As you all know, 100, whenever we are taking out percentage, it is always multiplied by 100. So in the same way, another way of calculating the mass by volume percentage is mass of a solute divided by the volume of a solution into 100. Again, as we are taking up the percentage, that is why we are multiplying it with 100. So separating the component of a mixture, when we are talking about the separation process of the components from the mixture, okay, we have already studied few of the methods like hand picking, sieving and filtration processes, but there are some mixtures which cannot be done by this hand picking, sieving and filtration process. For that we need to undergo another kinds of separation process. So today we are going to talk about the evaporation, centrifugation, decantation and sublimation reaction, and rest of the other topics we will be studying in our next video. So first of all, let's talk about the evaporation process. So what is the principle behind the evaporation process? Where do we use this evaporation process in separating the two mixtures? So this method can only be used when there is a volatile component, that is the solvent, from a non-volatile component or solute by heating the mixture. That means volatile and non-volatile. Volatile means which readily burn, and non-volatile means it does not readily burn under the heating. So for example, they have done an experiment with the ink is a mixture of dye and water. Okay, so ink is a mixture of dye and water, so we need to remove the dye and the water. So what they have done, they have taken some ink into a china dish. You can see this part. This is the china dish. Okay, this is called as the china dish. You must have observed in the laboratory also. Okay, so when you will start heating the china dish under the burner, okay, start heating, what will happen? The water which is present in the dye, that means the mixture of water and dye, that is ink, the water which is present in the ink, it will evaporate. Okay, and the dye is left in the dish, and the dye is left it in the china dish. So in this way we can separate the mixture of the salt and water as well as in the sugar and the water by the evaporation process. So next process is the centrifugation. What is the centrifugation? So centrifugation process is used in separating the denser particles and lighter particles. Whenever there is the combination or the mixture of the denser particle and the lighter particles, we can undergo the centrifugation process. So this centrifugation process occurs by a machine called as the by using the centrifuging machine. Centrifuging machine does the centrifugation process. So for example, we can take some milk in a centrifuging machine which spin rapidly, like it rotates very vigorously, or it rotates very very fast, in which the cream can be separated from the milk because the cream is less dense than the milk. So in this way, by the centrifugation process, we can separate the denser particles from the lighter particles. Next one is the decantation process. So decantation process by using the separating funnel. Decantation process you must have studied in your lower classes. What do you do? If there is a beaker, okay, and there is the mixture of water, if there is a mixture of water and the soil into it, for example, these are the soil into it. If you will keep this mixture separate for some time, what will happen? In this beaker, if you will keep it undisturbed, what will happen? The soil will settle down at the bottom and the clear water will be on the above part. So what you will do, you can easily take this clear water out slowly. So this process is called as the decantation process. So but here what we are going to use, we are going to use a separating funnel. So this is the separating funnel. So what we can do in this mixture, one example they have given, and yes, what is the principle behind it? This decantation process can be used only when there is the difference on their densities. The mixture should have different densities. For example, kerosene oil and the water. Okay, if you add kerosene oil and the water into this funnel, what happens? The water can be separated by opening the stop clock. This is the stop clock. Okay, it is given lower at lower one. Okay, so what will happen after the water flows out of the stop clock can be closed? So can you see this one? This is the water and this is the kerosene. So what they are doing, as these two do not mix together, so what we can do, because of their difference in the densities, the water will have one layer and the kerosene will have another layer. So what we can do, we can separate this water first, and when all water is finished up, then we can separate this kerosene differently. Next one is the sublimation process. Sublimation process, as you all know, what is sublimation? The conversion of the solid directly into the gas. Okay, this is called as the sublimation process. So as I was telling, the sublimation is conversion of the solid directly into gas without undergoing the liquid process. In the same way, when it is cooled down, this gas will be again converted into solid. So this process is called as the sublimation process. Okay, and this sublimation process can be used up when there are the two components which is sublimable and which is not non-sublimable, means which cannot sublime and which can sublime. Okay, for example, they have taken a mixture of ammonium chloride and the common salt. So this is the china dish which contains the mixture of ammonium chloride and the salt. So when you will heat it under the burner, what will happen? Ammonium chloride, it can sublime. Okay, directly from here it will be converted into the vapors. Okay, what will happen? It will be converted into the vapors, and when all the ammonium chloride will be converted into vapors, you just turn off the burner. Once the burner is turned off, what will happen? These gases which escaped here, okay, the gases which went up, it will be cooled down, and again it will be deposited on this sides. Can you see over there? This can be deposited on this funnel, sides of this funnel. So that means this is that is how we can separate the ammonium chloride solidified, and here at the lower part we only the common salt is left out. So this is how we can separate the two mixtures of the ammonium chloride and the common salt, because the ammonium chloride can sublimes and can be cooled, and then it is solidified and can be collected, and salt is left behind at the china dish. So this is about the sublimation process. So today we studied about the 4 different process for the separation of the mixture. In our next class, we'll be talking about our other processes. Till then, bye bye everyone.